أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Evaluating Reflective Measurement Model SEMinR series. Now we have done how to summarize or how to show reliability, validity, but we haven't discussed how to evaluate our reflective measurement model. Now a model could be reflective or formative. Although we have discussed a basic distinction in them in our previous sessions, I strongly recommend that scholars who are not well aware of the difference should watch the video that is shared in the description. The focus of this session will be how to evaluate a reflective measurement model. Let's say this is our model that we want to test. We've got 3 IVs, then we've got this endogenous variable and this variable, or let's call it the ultimate dependent variable. For now, I'm not interested in checking or assessing the mediating role of collaborative culture in the relationship between vision development, rewards, and organizational performance. There will be more sessions on how to assess mediation analysis using SEMinR package. But for now, the focus is on evaluating a reflective measurement model. Reflective measurement model. This section will describe how to evaluate the quality of reflective measurement models estimated by PLS-SEM, both in terms of reliability and validity. So as we all know, or if you do not know, please again go to and identify the difference between a measurement model and a structural model. Now in structural equation modeling, we've got 2 types of models, basically that shape up your structural equation models. Measurement model that discusses or is focused on assessing the reliability and validity, and structural model that establishes the significance of relationship between different constructs. In this session, the focus is on reflective measurement model. This particular topic of reflective measurement model assessment is divided into multiple sessions. Now, assessing reflective measurement models includes evaluating reliability, both at indicator level and a construct level. At indicator level, it's called indicator reliability, and at the construct level, it's called internal consistency reliability. Now, validity assessment focuses on each measure's convergent validity that is established using average variance extracted. Moreover, the heterotrait monotrait ratio of correlations allows to assess a reflectively measured construct's discriminant validity. So we are going to use HTMT for discriminant validity and AVE for convergent validity. Now, these are the steps that we will follow to establish the reflective measurement model or evaluate our reflective measurement model. Step 1, we will assess indicator reliability. Step 2, we are going to assess the internal consistency reliability. Step 3, we will assess the convergent validity, and step 4, we will assess the discriminant validity. Again, the first step that you have to undertake when you are using a SEMinR package or maybe any software, you have to specify your measurement model. In SEMinR, we do it through coding, and what we do is we simply identify our constructs and their items. We continue analyzing the simple PLS path model introduced previously with vision development and rewards as independent and collaborative culture as dependent variable. However, in this case, I've added one more variable, organizational performance. Now in the following, we discuss how to evaluate reflective measurement models using the simple model as example, and that model was described previously as this. This is the model we are going to evaluate as part of this series of sessions on evaluating reflective measurement model. Recall that to specify and estimate the model, we must first load the data and specify the measurement model and structural model. The model is then estimated. Now this is the process. The first thing is you have to load the library, then load the data, then specify the measurement model and your structural model. Then you have to estimate your measurement model. And for estimation, we are going to use this function, or we have rather used this function. That what happens is, once you call this function, the output is assigned to an object. In our case study, we name this object as simple_model. Once the PLS model has been estimated, we can access the reports and analysis results by running the summary function. To be able to view different parts of the analysis in greater detail, we suggest assigning the output to the newly created object we call summary. So once you have estimated the model, you create a summary of that particular model, and by calling the summary function. And once you call the summary function, the results are assigned to this particular object of summary_simple. Now, how do you do this? You load the SEMinR library, you load your data. Look at this double backslash, because a single backslash is normally referred to as an escape character in programming languages. All this data, when read, is stored in this object. Now make sure, just review that you have loaded your data correctly. Now this is how you specify your measurement model. Now in this case, all of them are reflective. How to do formative? This is coming up in our next lectures. So first constructs and then composites. What are composites? This was defined and explained in the last session. Vision is one of the construct, development, reward, collaborative culture, organizational performance. These are the names of the constructs that I want to show in my model. But these are the names that I have given in this data sheet here. Viz 1, 2, 3, 4. Dev 1, 2, 3, 4 up until 7. Similarly for the rest of them. Now there are multiple items measuring this particular construct. Now make sure you are well aware of the brackets, the commas, because anything you miss will result in an error. Once you have specified your measurement model, the next thing is you have to specify your structural model. Now in this case, have a look here. What I've done is vision, development and rewards is linked to collaborative culture, and then collaborative culture is linked to organizational performance. I'm just going to run this model. And again note, I've left a few errors in the code. The reason being, if it's too perfect a code and doesn't give an error, you won't understand what gives an error. What are the errors that you might face, or common errors that you might face when writing your code. Now this is how you estimate your model. And once the model is estimated, that is, as we used to do in Smart PLS, just go to calculate PLS algorithm. Now, once you've got your estimation done, you have to call the summary function to retrieve or summarize your model results, and they are put in this object. Now, how do we do this? Let me go back and simply, step by step, let me copy this text. Now I've got this here, all this, but I'm going to do this again just to see what errors we get so that we understand the common errors that we might face. Okay, all this. Now let's run it. No issues here. Moving on. Let's create our measurement model. Let's put it here and let's see what we get. Now look at this error, unexpected input in this. So there is an error in collaborative culture. But this seems fine to me. There is no error. However, if you look at this here, this is green. But look at this here. This variable did not turn green. Why? Look at the inverted commas here and look at the inverted commas here. So if you are copying the text from any other source, just make sure you put in the inverted commas again. Make sure you clear the spaces and then add the spaces again if you want to. Now in this case, let me first clear out these inverted commas from both sides and now add one here and add one here. Now look at this again. This CC is green, but here the prefix to my indicators for organizational performance did not turn green. Again, the reason is inverted commas. So just put in these codes here again. Now this looks fine. Now let's run it and have a look. Now it did run fine, no errors. So you have corrected the errors, you have corrected the mistakes. Moving on, let's create our structural model and see if we get an error or errors. Now let's copy this, run. Again we are having errors. Why? Look at this, this is green, but look at this, this is all black. Again the problem seems to be with your quotations on the format of the quotes. Just put it back in here, here, and again let me remove these. Let me remove these again, and again one here, one at the end. And now let's run our specification for structural model. Now look at this, it ran fine. Now let's me put this window back here, so I can obviously later, if I want, I can simply just drag it. Now moving on, if you are establishing multiple paths, they are separated by commas, just as your composites are separated by commas. Now this is the syntax of R. Now obviously the more you practice, the more you will learn the syntax. Now look at this, if I click here, this bracket here is the closing bracket for this bracket here. Now this bracket here is the closing bracket for this one, this opening bracket here. So as you move towards the bracket, it shows you the opening and closing brackets as well. Now moving on, let's go to our next step. Now let's estimate and see if we get any error. Copy, and let's put it here, and let's estimate our model. Now you have, because it's a stepwise procedure, you have specified what your measurement model would be, what your structural model would be. Now you have to estimate the model, run the estimation procedure. So let's run it. Okay, now no errors. All 341 observations are valid. Now that you have estimated the model and this is stored in this particular object, I need to see the results. Now where are my results? You have to summarize your model results. I'm calling the summary function, and what do I want to summarize? I want to summarize the simple underscore model. And once the summary function is called, all that is returned is stored in this particular object. So let's run it. Now where are my results? How do I get my results? We are going to discuss this now. Let's see the results, or let's first look at this particular slide. Note that the results are not automatically shown but can be extracted as needed using the summary underscore simple object, where we assigned all our summarized result from our estimated model. For a reminder on what is returned from summary function applied to SEMinR model and stored in the summary underscore simple object, refer to table 2 here. Now this is what is stored in summary underscore simple object. How do you access it? Just write summary underscore simple, add the $, and then add whatever sub-object you want. Now before analyzing the results, we advised first to check if the algorithm converged. That is, the stop criterion of the algorithm was reached and not the maximum number of iterations. See table 1, like this table, for setting up these arguments in the estimate PLS function. So how do you set up this in estimate PLS function? To do so, it is necessary to inspect the iterations. Again, just call in summary underscore simple with this $, and then iterations. Look at this. Let's do this. Summary underscore simple, $, and then iterations here. Just click here. Now let's look at this. So it did not reach the maximum iterations and it converged in just 5 iterations. So we are good. This number should be lower than the maximum number of iterations, that is 300. The next thing is, if the PLS-SEM algorithm does not converge in fewer than 300 iterations, now if it does not converge in your 300 iterations, which is the default setting in most PLS-SEM software, the algorithm could not find a stable solution. Now this kind of situation almost never occurs. And yes, it does not. Because in my experience of last 3-4 years, I've never seen a model that did not converge. But however, if it does occur, there are two possible causes. The selected stop criterion is set at a very small level, that is this instead of this. So the small changes in the coefficients of the measurement model prevents the PLS-SEM algorithm from stopping. Or there are problems with the data and it needs to be checked carefully. For example, data problems may occur if the sample size is too small, or if the responses to an indicator include many identical values. Obviously, this will also result in singular metrics. In the following, we inspect the summary_simple object to obtain statistics relevant for assessing construct measures internal consistency reliability, convergent validity, and discriminant validity. Now, these are critical criteria to assess a measurement model. Now, the first step is indicator reliability. Now, how do you assess indicator reliability? The first step in reflective measurement model assessment involves examining how much each indicator's variance is explained by its construct, and this is called indicator reliability. Now, to compute an indicator's explained variance, we need to square the indicator loading, which is the bivariate correlation between an indicator and the construct. Now, in order to get your indicator reliability, what you need to simply do it is just take the square of your loading. And the loading will obviously tell you how well a particular item is representing the underlying construct. And it is the bivariate correlation between the indicator and the construct. Now, as such, the indicator reliability indicates the commonality of the indicator. Now, indicator loadings above 0.708 are recommended, since they indicate that the construct explains more than 50% of the indicator's variance, providing an acceptable indicator reliability. Now, researchers frequently obtain weaker indicator reliability, that is less than 0.708, for their measurement models in social sciences studies, especially when newly developed scales are used. Now, rather than automatically eliminating your indicators when their loading is less than 0.70, researchers should carefully examine the effects of an indicator reliability. Researchers should carefully examine the effects of indicator removal on reliability and validity. You just do not go on and remove your indicators because their loading was less than 0.70. You assess whether this removal will significantly improve the reliability and validity. Now, if your reliability and validity is already above the required limit, you do not need to go on and delete an indicator because its loading was less than 0.708. Now, generally, indicators with loading between 0.40 and 0.708 should be considered for removal only when deleting the indicator leads to an increase in internal consistency reliability or convergent validity above the threshold value. Now, if you had reliability and validity below the threshold value and your indicator loading was less than 0.70, let's say it was 0.40, 0.50 or 0.60, now you only remove it if it significantly improves your reliability and validity above the threshold value. Now, another consideration in the decision to whether delete an indicator is the extent to which its removal affects content validity. Now, we have to be very cautious. If the removal affects content validity, we have to be very considerate about it. Now, as a consequence, indicators with weaker loading are sometimes retained. Now, indicators with very low loadings less than 0.40 should, however, always be eliminated from your measurement model. Now, how do we assess indicator reliability in SEMinR? Now, again, we have got our summary_simple object, and what we need to do simply is just use the $sign with summary_simple object and get our indicator reliability. Now, how do we do this? This is the code. Now, this will give you the loadings and this will give you the indicator reliability, that is the square of the loading. Again, this square of the loading should be over 0.50. Now, variance is explained by taking square of the loadings. Indicator reliability is established if it's over 0.50. Now why 5.50 and why this value of 0.708? Because when you calculate your AVE, then obviously you need each item to have at least loading of 0.708. But what happens is some of the items have higher loading, some of them may have lower loading. So those that have higher loading actually compensate for those items that have got lower loading. But in this case, just be mindful that this is how you access the loadings. That is, the required limit is 0.708. However, we have just seen that you do not remove items just because they've got low loadings. And again, we will use this code to assess whether or not our indicator reliability is established. Now, how do we do this? Let's have a look. So I've got my data or results in summary underscore simple. So let me call summary underscore simple, and then let me add my $sign. And now I'm interested in loadings, plus I'm interested in establishing indicator reliability. So just paste it here, just add this sign here with a 2. So you are squaring your loadings, and this sign is, you get this sign by pressing Shift and 6 on your keyboard. Now just select it and let's run it. Now let's move it a bit up. Have a look here. Loadings, all good, 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 good. And this is the square of the loadings. Have a look here. So 0.90 if squared will give you 0.829, 0.805, 0.809. Now all of this is obviously greater than 0.50. So indicator reliability is established. So there is no issue of reliability, or for now we can say indicator reliability in your data. The next step is reliability and validity at construct level. Thank you very much.